We need to find the sine of two angles added together and the tangent of two angles together. And the only thing we're given is that our two angles of alpha and beta are in the second quadrant, and that the sine of alpha is 2/3, and that the cosine of beta is negative 1/3. The first thing you want to do is you want to draw an angle to represent each one of our given ones. So we'll draw a triangle in quadrant 2 for alpha. Remember, in drawing your triangles, you always come out from the origin and then make it perpendicular to the x-axis. Now, since sine is 2/3, we would know that sine is opposite over our hypotenuse. Also remember, when you're drawing your triangles, that the angle alpha that we're dealing with, or any angle you're dealing with, is always at the origin and an acute angle in your triangle. Well, we'd have to use the Pythagorean theorem then to be able to get the missing side. Our missing side squared plus our 2 squared equals our 3 squared. We solve that for our missing side, and we get the square root of 5. But we do know it's negative since we're going to the left. We need to do something very similar for our beta angle. Since beta is in second quadrant, we got to draw a second quadrant in, or a second angle in quadrant 2. Do a totally separate axis. Make sure you label these, because when we get to our formulas, you're going to have to know, am I going to the alpha angle or the beta angle? Now here, you know the cosine of beta is adjacent over your hypotenuse. So then you'd have to use the Pythagorean theorem again to be able to figure out your missing side. Negative 1 all squared plus your opposite side squared equals your hypotenuse squared. You solve that for your opposite side and you get 2 root 2. We know it's positive and not negative because we're going up. Now that we have our angles drawn, we can go ahead and work out our problems here. The first thing you want to do is to figure out the sine of alpha plus beta. The formula for the sine of alpha plus beta is given to you here. So you go the sine of alpha. Well, that means I got to go to my alpha, take the sine, which is 2/3 because it's opposite over hypotenuse. Then it says cosine of beta, so I need to go to my beta angle. Go adjacent negative 1 over my hypotenuse, so 3. Then I need to do the cosine of alpha, so I go to my alpha. Cosine would be adjacent negative root 5 over my hypotenuse. Over the sine of beta. So I need to go to my beta. Sine is the opposite, 2 root 2 over my hypotenuse of 3. So now all we have to do is multiply fractions together. Multiply the tops. Multiply the bottoms. Here, multiply the tops, multiply the bottoms. Since it's both going to be over 9, I could write it as one fraction. Multiplying your roots here, you multiply what's in front. The 2 times the negative gives us the negative 2. Multiply the 2 roots together, and we get the square root of 10. We also need to do that with our beta, or our tangent of alpha plus beta. So here's the formula for the tangent of alpha plus beta. So we need to do the tangent of alpha. So go to alpha, tangent's opposite over adjacent. Then we need to do tangent of beta. Beta, tangent's opposite over adjacent. And then we'll go 1 minus tangent of alpha. That's what we had right here. Times beta, tangent of beta, which is what we had right there. Now all we have to do is to go ahead and simplify this. Well, if we take our original here, we wanted to eliminate our fractions within a fraction. So let's go ahead and multiply the top and the bottom by that common denominator. our root 5, because we have this being over 1, distribute this through, our root 5 times 2 over our root 5 would be just a negative 2. Our root 5 times this here, it'd be a negative 2 in front. Multiply your two roots together, you get root 10. Then on the bottom, we want to take this right here, distribute that through to the 1 in front. So it'd be 1 times root 5 or root 5. Notice here, this negative drops out with this negative. When we multiply root 5 times this part right here, this root 5 would undo that root 5. So we'd have our 2, and our root 2. And the 2 times the 2 is your 4. Now, when you look back over here, negative 2 minus 2 is a negative on top over a positive on the bottom is a negative answer. When we look at this, we get a negative on the top. If you work out the bottom, it would be negative. A negative over a negative is a positive. So which quadrant is alpha plus beta in? Well, if your sign is negative and your tangent is positive, there's only one way that can happen. When is sign negative? That's in quadrants 3 and 4. When is tangent positive? That's in 1 and 3. Well, the only quadrant that's overlapping between these two possibilities is quadrant 3. So we know our answer is in quadrant 3 for our alpha plus beta. Now, our initial problem that we started out with could have been represented as what we have right here for the sign of alpha plus beta. Or the tangent of alpha plus beta could have been represented as this. By the end of the chapter, we'll be representing this problem in this format.